R.7 Notes, Part 3. Okay, for number 1, we're going to simplify the square root of 160. Make sure that you know how to show work for this for whenever you take your test. So to simplify the square root of 160, I want to first note that there is a 2 right here for our index. Anytime we don't see a number, we know that it's 2. So since it's a 2, we're going to write out all of our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, and 13 squared. Now I'm stopping here because 160 would fall right here in between 144 and 169. So now we need to find the biggest of these numbers that divides 160. One way that we can do it is just divide each 160 by each of these. So 160 divided by 144 is not a whole number. 160 divided by 121, not a whole number. 160 divided by 100, not a whole number. Same. Here, we get 16 times 10 gives us 160. So I'm going to rewrite this as square root of 16 times 10. I picked 16 because it's the biggest perfect square that divides 160. And 16 times 10 still equals 160. So now I can take the square root of 16 and get 4. And then 10 stays in my radical. If this had been a cube root up here for the index, then we would have done the same thing, except we would have listed out all of our perfect cubes, 1 cube, 2 cube, 3 cube, 4 cube, so on, and found the biggest perfect cube that divided 160. Okay, for number 2, we have -3 times the 5th root of 32. So since we have a 5th root, we need to think about our perfect fifths. So 1 to the 5th would be 1. 2 to the 5th is 32. So that means that the 5th root of 32 is just going to be equal to 2. So in the end, we get -6. Number 3, I don't have an index on my radical, so I know that it's going to be a 2. And anytime we have variables, we're just going to think about pulling out our x's or our y's in groups of, in this case, 2, because that's our index. So you can kind of think we've got 3 x's on the inside. How many groups of 2? We've got 1 group of 2 and then 1 x left over. So 1 group of 2 comes out, x to the first, and left inside is another x. It's my remainder. Another thing we can think, 3 divided by 2, we're going to get out 1 group of 2 and then a remainder of 1. Okay, y to the 8th. 8 is divisible by 2, so we can just go ahead and divide that. 8 divided by 2 is 4, so I have y to the 4th on the outside. I didn't have any y's remaining on the inside because 8 evenly divides 2, or 2 evenly divides into 8. Okay, number 4, now we have a cube root. So let's start with simplifying the cube root of 81. So we need to think about our perfect cubes. I've got them started up here. Or no, those were fifths, weren't they? So perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. So 81 falls right here. 81 divided by 64 is not a whole number. 81 divided by 27, we're going to get out 3. So for the cube root of 81, we're going to rewrite that as cube root of 27 times 3. We can take the cube root of 27 and we get 3. So we get 3 cubed root 3. It's a lot of 3's going on. So now let's look at our x, y, and z. So in my final answer, I'm going to have a 3 outside, and I'm also going to have a 3 left in my cube root from down here. So let's start with the x's. We have 5 x's. 3 goes into 5 one time, so we're going to pull out 1 group of x's, and there are 2 x's left over in the radical. y to the 7th. 3 goes into 7 2 times, so I'm going to pull out y squared, and there's going to be 1y left over on the inside. And z to the 6th, 6 is divisible by 3, so 6 divided by 3, we get 2. So we have z squared on the outside and no z's left on the inside. So when you get to a problem like this, start with the number. In this case, it was 81. And then do your x's, then your y's, then your z's. It's almost like 4 little problems in one problem. Okay, number 5. Anytime we have a radical with a fraction in it, first see if you can simplify your fraction. In this case, we can't. 5 and 2 don't simplify. So I'm going to rewrite this as the square root of 5x over the square root of 2. I can't simplify the square root of 5x. I can't simplify the square root of 2 because no perfect squares divide 5 or 2. But I do need to rationalize this. It's improper to leave a square root in your denominator. So I'm going to multiply the top and the bottom of this by square root 2. Again, we're rationalizing. On the top, I've got 5x times 2. So that would be the square root of 10x. On the bottom, we can think of it as one of 2 ways. First of all, if we multiply a square root times itself, so square root 2 times square root 2, we just get what's on the inside. Or you can go ahead and multiply your 2's together. Square root 2 times square root 2, we get square root of 4, which again is just 2. We can't simplify 10 and 2 because 10 is in the radical and 2 is not. So that's your final answer. Number 6, whenever we're adding or subtracting radicals, we first of all need to make the radicand, the inside of each radical, the same. So let's look at this as 3 different problems. Let's start with the square root of 18x. We can simplify the square root of 18x by finding the biggest perfect square that divides 18. Let's write those out again. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared, 7 squared, 8 squared, and then that's plenty for what we've got going on here. So 18 would fall right here. 16 does not divide 18, but 9 does divide into 18. So we're going to write this as 9 times 2x. The square root of 9 is just 3. So we get 3 square root 2x. Plus, this middle term already has just a 2x on the inside. We can't simplify it, so we'll just bring that down. And then our third term, the biggest perfect square that divides 50. 50 would fall here. Can't divide 49 into 50. Can't divide 36 into 50. But we can divide 25 into 50. So we're going to write this as 25 times 2x. Square root of 25 is 5. So now we can just combine these because we have like radicals. So 3 square root 2x plus 1 square root 2x minus 5 square root 2x. 3 plus 1 minus 5 gives me negative 1. So it's negative 1 square root 2x, or just negative square root 2x. And our last problem here. Again, this is an improper expression because there is a radical in the bottom. So we need to rationalize it. So I'm going to start by rewriting the problem and multiplying the top and the bottom of it by my favorite form of 1. Remember, 1 is just anything that's the same on the top and the bottom because that would equal 1. What I'm going to multiply by is the conjugate. So take our denominator, 5 minus square root 2, and we're just going to change the sign. So it's going to be 5 plus square root 2. Again, I got this conjugate by taking my denominator and changing the sign from a minus to a plus. Okay, on the top, we're just going to distribute square root of 3. So we get 5 square root 3 plus square root 6. On the bottom, we have a binomial times a binomial. You can do this one of 2 ways. You can either FOIL or you can use box method. I prefer box method, so I'm going to do that down here. So we've got 5 and minus square root 2, 5 and plus square root 2. 5 times 5 is 25. 5 times square root 2 is just 5 square root 2. 5 times negative square root 2 is negative 5 square root 2. And square root 2 times square root 2 is just going to give us 2, but it's going to be a negative 2 because one of those was a positive and one was a negative. Notice that these two terms cancel out. 5 square root 2 minus 5 square root 2 is 0, so those go to 0. So in the bottom, I just have 25 minus 2 left over. So my final answer, let's move down here, is 5 square root 3 plus square root 6 all over 23.